Lesson 21, we're going to be solving one-step equations by multiplying or dividing. Now, we're building very slowly, albeit, the building blocks and skills that are going to be necessary for solving multi-step equations that are coming up in this unit. Okay? Solving multi-step equations, particularly solving a two-step equation, is foundational to being able to solve more complicated equations that are coming down the pipeline. What is algebra?
Algebra is a branch of mathematics with the involvement of numbers and letters and equations.
Yeah.
Algebra is a branch of mathematics where we learn the skills to solve all types of equations.
It's a skills class. We're learning the skills that are necessary to solve all types of equations. The foundational fundamental theorem of calculus says there's 5 solutions to a 5th degree equation. There's 6 solutions to a 6th degree equation. In my college algebra class, we're still building skills. We're still not solving those higher skills. Later in the section, you could call it an Algebra 3 class, you actually learn to solve 5th degree equations and find all solutions, right? So you're building towards something that you're not doing yet. And that's one of the reasons that algebra is a little bit, dissatisfying. Okay, so we've got, today we're simple. But don't pass by this. We have to do this very simple skill with 100% efficiency. If we're not doing it with 100% efficiency, we're going to miss a lot of problems that we should not miss. Okay? So don't take any of this for granted. Write this stuff down and go. Now, so here's a review. Inverse operations. To find a solution of equation, we're always going to isolate the variable. What do we mean by isolate the variable? Yeah, Sean? Get the variable by itself. And we do this using inverse operations. So you must use the same inverse operation on each side of the equation. If we add something to one side of an equation, we have to add it to the other side to keep the equation in balance. If we multiply something on one side of an equation, we have to multiply it on the other side to keep the equation in balance. All right? So whatever we do to one side, we must do to the other. These are called the properties of equality. Properties of equality are the properties of equations. Equality, equations, right? We can add or subtract something from both sides. That's called the addition property and subtraction property of equality. We can multiply or divide both sides of an equation by anything but 0. That's called the multiplication property of equality and the division property of equality. Okay? There's a couple of other properties. The symmetric property of equality says we can swap both sides of an equal sign. The reflexive property of equality says everything is equal to its reflection itself. Okay, so that's called the reflexive. Those are the properties of equations. What are we allowed to do to equations? We have a lot of leeway when we're solving equations. Okay? So here's a statement of the properties that I just alluded to. The multiplication and division property of equality says, you don't need to write this down, both sides of an equation can be multiplied or divided by the same number and the statements will still be true. Here's an example here that shows that. On the left we have an equation, right? 2 equals 2. Is that a true equation? Yes, everything is equal to itself. That's the reflexive property of equality. If I multiply both sides by 3, I get a 6 equals 6, which is still a true statement, right? Okay? And it works for variable expressions too. If A equals B, then we can multiply both sides by C and we get AC equals BC. It works for division also. Now, of course, this does not work if we're multiplying by 0, and you can never divide by 0. You can't just multiply an equation by 0 and blow it up. 0 equals 0. Right? It'd be an easy way to get out of doing equations. I don't like this one. Just multiply both sides by 0 and there's no more equation. Right?
Yeah.
Okay. Can't do it. Okay, so here we go. Solve, then check the solution. Now, if I give you instructions like that, I'm expecting to see process. Okay? So, I think that a lot of you could tell me that what number divided by 6 is equal to 8, right? 48. Yeah. But what's the process of solving this equation? Because I can certainly give you an equation that you can't do mentally, And you're going to need to know the process for solving that one. So if we are dividing by 6, how do we undo that, Karis? We multiply both sides of this equation by 6, right? 6 times that side, 6 times the left, 6 times the right. Okay? Multiplication by 6 undoes division by 6. They are inverse operations. So the 6's cancel, and we're left with x equals 48. How do you check that equation?
48 divided by 6.
You substitute the value back into the original equation, right? And we want to make sure that we've done this correctly. 48 divided by 6 equals 8. Is that true? It is absolutely true. Okay, what about this one? Negative 11 equals W over 4. Now, this equation is a little different, right? Talk to me about what's different about this equation. Josh? It has a negative in it. That makes it different from the previous one. What else is different?
The answer is first instead of the...
The variable is on the right instead of the left is what Jay's trying to say, and that's also true. That's correct. And that bothers some people. It bothers me. I don't like it. I just don't like it. I like the variable on the left. Can we fix that problem? It's not really a problem, but can we fix it? Yes. Because one of the properties of equations is that it is symmetric. The symmetric property says if A equals B, then B equals A. Now what is that really telling me that I have permission to do? I can swap sides of the equal sign anytime I want to. So if you are bothered by the fact that this variable is on the right, you can, right out of the blocks, write it this way. You don't ever even have to write it the way it's given to you. Just swap sides. Now, we can't do that with inequalities unless we also flip the symbol, but inequalities come much later. Okay. Now, how do you finish solving this? You multiply both sides by 4. Why are we doing that? To undo division, you use multiplication, right? So the 4's cancel, and we're left with W equals negative 44. How would I check that? Substitute that right in there for W. Is negative 44 divided by positive 4 equal to negative 11? Yes. So we have a solution. Right? Okay, what about this one? I know these are very simple, but again, process is so important, even in the simple problems. Because a little bit later, you're going to be forced to use process. So what do we do to solve this? Yes?
You divide 5x by 5, and you get x, and then on the other side you divide 20 by 5.
Right, so we divide both sides by 5, right? And that gives us x equals 4. And how would we check that answer? In your original equation, we take our solution and plug it back in. We want to make sure that 5 times 4 equals 20. Do you have to do that? Should you do that?
Absolutely.
Every single problem you should check. It's so easy, right? And we've already shown one example earlier where I said 1/3 and wrote 1/2. How often do you think a number and write a different number? Right? So maybe you'll catch that error if you check your answer. If you don't check your answer, you surely won't. Our minds are messed up. What's up, Cooper?
If like on like a quiz or a test, if we forget to check our answer, will we count off?
No, I wouldn't do that. I wouldn't do that. You know, unless the quiz question is to check this answer. You know, that's why we do the skills. That's why one of the bell work problems today was, what do you get when you plug this in? They want you to get used to plugging things back into an expression and evaluating it and see if you're getting a true statement. Because if it's the solution, it will result in a true statement. Okay? All right. Example 4. Use careful processes. Don't make mental mistakes. The only reason you cannot make mental mistakes is to do very little mental math. You want to actually do the processes. It doesn't take that much time. You don't want to save 5 seconds and miss a problem. Okay? So what would we do here? Do we have to work it this way? Can we swap sides if we want to? Yes, but we don't have to, right? Cooper, what would we do?
You would do 3 divided by 3.
Divide both sides by 3, right? Negative 12 divided by 3 is negative 4. Negative 4 equals n. Same as n equals negative 4. Plug that right back in. Make sure. What's 3 times negative 4? Negative 12. Negative 12 equals negative 12, so we're in good shape. All right? A couple more and we're done. Now here's one where you have to know your processes because this is not going to give us a nice, easy, clean solution like the other ones did, is it? Ooh. I was telling Abby something. You want to work an equation, you work top down. You don't go over to the side and do something to the side. Okay? I always want to work the next step right below it so you can see a linear progression of things. And that's just a process that will help you when the equations get more difficult.
So if you have like side work, you do it on your bottom?
Yeah, here's what I don't want to ever see you do with an equation. Now, a simple equation like this, maybe it works okay, maybe it doesn't, but I don't want you to work this equation out here to the right. Your second step shouldn't be over there. Your second step should be immediately below, and the equal signs need to line up. Trust me. Yes, Karis?
Okay, if we have a problem where it's like 4 divided by 2 equals x or something, but it has it the 4 divided by 2 in fraction form, does it bug you if we like write it the other way?
With division symbol?
Yeah, it helps us with
You know, I don't have a problem with that. I just don't see where it would be all that useful. Did you do this way?
No, I'm just saying, like, sometimes when it's, like, a really long I don't like it.
Yeah, I mean, I'd have to see a specific example of what you're talking about. When one comes up, remind me of this. I'm not exactly sure what you're asking. I'm not sure. So somebody tell me what to do here. Griffin, help me out. Divide both sides by 2/5. I like that. Just like we've been doing, right? But this is going to cause us, and this is where I was saying, I want to bring the equal sign straight down. P equals, now on this one, 7 divided by 2/5, is that what you meant?
Yeah, like 7 divided.
Yeah, instead of showing it as a fraction bar, would it be okay to do 7 divided by 2/5? Is that what you were asking? Absolutely, that's fine. Yes, that's great. That's actually a little easier to deal with that way, isn't it? Because 7 divided by 2/5 is the same as 7 times 5/2, which is equal to 35 over 2, which we're going to leave as a fraction. Yes, Tati?
When you go to do 7, if you wrote it like that, when you go to do it, could you go ahead and flip it?
You know, you could, but you need to be careful combining too many steps in one. That's leaving a little too much in the deal. Now, if you're going to do it that way, what I would prefer that you do right from the outset of this problem, we know that dividing by a fraction is the same thing as multiplying by the reciprocal, right? So, instead of dividing both sides by 2/5, what could we do at the very beginning? Multiply both sides by 5/2. and then we can jump straight to the solution. So if you're going to change it, I'd rather you do it this way. So the 2's cancel, the 5's cancel, we're left with P equals 35 over 2. And this takes us back to lesson, I forget what lesson it was, but there's a, it's the inverse property of multiplication or multiplicative inverse. If you multiply a number by its inverse, it's equal to 1. So we can do that. All right, one more example. Anita is an architect. She's designing a rectangular room that has an area of 126 square feet. The length of the room is 12 feet. What is the width, right? So we're dealing with the area of a rectangle. So what should we write down? What formula are we working with here? Area equals length times width. And then what should we do? Substitute things in. 126 equals 12 is the length times W is the width. And now we have an equation that we want to do. I want to see this process in these problems. Okay? Because when you get to much more complicated formulas in chemistry and physics and you're making these substitutions, you will not be able to do it mentally. You're going to have to start with the formula, and you're going to have to evaluate things using the formula. Geometry, too, is still very important. Work with the formula. Divide both sides by 12, and we get what? 10.5. W equals 10.5 what? Feet. Okay? That is what we're going to work with. Your homework is
Please give it to me.
page 123, A through G, 1 through 29, odd.